In this video, I'm going to show you how Nodal's different node types change the way signals travel through a nodal composition network. To illustrate this, I've got a very simple example that consists essentially of 4 nodes connected into 2 loops. So this first node on the left is where signals enter, and there's only one possible pathway for a signal to travel, and that's to this node on the right. But this node has 2 exiting edges, one coloured orange and the other coloured green. And you'll notice in the node editing window that this corresponds to the color of the chips in the editor, and the signaling type is set to sequential. So what this means is that a signal entering this node will first go through the orange pathway, and then the next time the signal comes around, it will go through the green pathway. So this effectively allows the signal to move through the top loop first, come back, and then go through the bottom loop. So let's play this network and hear what that sounds like. So you can hear that it's cycling through the top loop first, coming back around and going through the bottom loop. In order to understand how the signal is moving through the network, it's a good idea to go to the View menu and select Show Node Counters. This shows the number of times a signal has passed through the network. And as you can see from the numbers that are being displayed currently, that the number on the top and the bottom loops is half of those through the main node here, the middle node here. Okay, let me just stop that. Now, if I want to change the number of times it goes through each loop, I can of course double click on any color chip and increase or decrease the number. So I'm going to change this composition to say that I want to go through the bottom loop represented by the green edge from this node twice and the top loop once. But I'm also going to change the ordering by dragging. So it will first go through the bottom loop twice and once through the top loop. And as I play that again, we should notice that the node counters change. Firstly 2 here for the 1 here, 4 and 2, 6 and 3, and so on. Okay, another tool that you can use to help you understand how a signal is traveling through a network is again to go to the View menu and turn on the Show Edge Signaling. This shows you the edge numbering, so first through the green, second through the orange, and the number of times in brackets that it will pass through each edge. All right, well, what I'm going to do now is change the signaling type from sequential to random. And you'll notice that the icon changes to having this little cross in the corner of the node. So with the signaling type set to random, it means that Nodal will randomly choose which edge to use when the composition is played and a signal comes through. But with the additional fact that the numbers here that were originally in sequential type set to the number of times it passes through equal to the probabilities. So it's twice as likely to go through the green edge or the bottom loop as it is to go through the top one, but this will be chosen randomly. So if I reset the network and press play again, you can see that it's not consistently choosing one or the other, but it's choosing them randomly. But it's more likely to choose the bottom one than the top one. Twice as likely to choose the bottom one than it is to choose the top. And if we start looking at the counters, we'll see that this counter is ahead 8 to 6, 9 to 6, 10 to 6, even 11. If I keep this playing for long enough, eventually these numbers would roughly turn out to be 1/3 and 2/3 of the value of this number here. And that's borne out by the probabilities that are shown by the edge display. Okay, the final type of signaling is parallel signaling. And what this does is it basically takes a signal that comes in through an incoming edge and splits it into 2 simultaneously if there are 2 outgoing edges. If there are 3 outgoing edges, it will be split into 3, 4 into 4, and so on. Now, you have to be very careful when using this kind of signaling type because we're basically creating new voices in a particular voice group that's traveling through this network. And if we have feedback in that network, it can lead to the number of voices expanding exponentially. So let me just play this briefly, and you'll notice that the number of voices traveling through the network increases very rapidly. So you can see that a signal entering here is simultaneously exiting through both edges at the same time, and that's creating two new signals that both come into this node at the same time, entering into the parallel node again, which of course splits them into two. So we have 2, then 4, then 8, then 16, and so on. Now Nodal will automatically clamp the maximum number of voices at the limit that gives you real-time performance. But generally you don't want to do this because it just gets louder and louder and builds up more and more signals in the network and makes it generally unusable after a while. So how do we get around this? Well, a good way is to try and eliminate some of the loops. So what I'm going to do is select this top edge here and delete it. So now a parallel signal coming up here will just simply finish at this point, and we should find that this eliminates the problem of the network overloading. Let's hit play and hear the difference. So this network will happily cycle around, and it keeps repeating because there's still one loop in play here, but both these nodes are firing simultaneously through the parallel node. I've now loaded a slightly more complicated network, although this network still only has 8 individual nodes. But as we'll hear in a moment, the complexity that this network can generate is quite interesting. And the reason it's able to do that is because of this single parallel node here that has 2 outgoing edges. So every time a signal enters this node, it will split into 2 and create 2 new voices within the current voice group. There's also a number of loops, some small loops here and a larger loop here that are operating within the network. And importantly, there's a single node here that has no outgoing edges. And we often refer to this as a sink node because it's like a drain for the excess voices that might otherwise fill up the network when we're using parallel nodes with feedback loops in them. The other thing that this network makes extensive use of is relative pitches. So you can see listed for the notes under each of the individual nodes that we're using positive and negative values rather than direct notes. So what this means is that every time a signal enters this node, the note that was played previously will be used minus 7 notes from that for the first time, and the same note for the next time. That's what plus 0 means. So of course the actual note that gets played depends on the incoming pitch, and as those pitches change, we can get more complicated harmonic sequences developing. The other thing that this network is using is a new feature in Nodal 1.9, which is the use of the Use Scale checkbox here, which confines all relative pitches to a particular key and mode. At the moment I've got it set to chromatic, but let's change it to Lindian, and that will ensure that any notes played, regardless of the relative pitch that has been generated by each note, keeps to this particular mode and key. Now I can change the mode and key while the composition is playing to get more complex harmonic information coming out of the network. So let's listen to this network now and hear or notice how the composition starts off very simple because it's just a single voice group playing a single MIDI synthesizer note at the beginning, but that will slowly expand as the number of voices increases. And of course this sync node is stopping that from overflowing, but you'll see the nodes start to divide up like a pie chart, which shows the number of voices that are playing each node at any given time. And that number will increase over time, but it will never overload due to the sync node.